Here we have two more examples of factoring trinomials when a is not equal to 1. In both cases, I can't just factor out. So when I look at this 3x squared minus 8x minus 3, nothing goes into all three numbers evenly. Actually, when I look at 9x squared plus 27x minus 18, something does go into all three of these evenly. If I look at this, I can actually pull out a 3 from all three things. So if I pull out that 3, that leaves me with 3x squared plus 7x minus 6, but we'll come back to that. With my original equation here in number 10, I'm going to want to make the cross. 3 times negative 3 gives me negative 9. Bring down the middle term, and I get negative 8. In order for two things to multiply to a negative, one has to be positive and one has to be negative. To multiply to negative 9, I can do negative 9 times positive 1. If I then add those two terms, negative 9 plus positive 1 gets me to the negative 8 that I'm looking for. So this tells me to rewrite my original equation, keeping the x squared term the same, but splitting this negative 8x into negative 9x plus x. Then I keep the negative 3 at the end. Pulling from the first two terms, when I factor by grouping, 3x can come out. That gives me 3x, x minus 3. For the second term, I already have x minus 3, so I'm not really pulling anything out. That said, I need something in front so that I can complete my factor by grouping and make sure that I'm getting outsides and insides. So even though I'm not really changing it at all, what I'm pulling out is an understood 1. If I think about it as multiplying back in, 1 times x will still give me x, 1 times negative 3 will still give me negative 3. So I know that can be a little tricky, but I am putting that one placeholder there just so when I go to do the next step, I see what the outsides are. So this becomes outsides 3x plus 1 times insides x minus 3. When I started number 11, I mentioned, hey look, I can put something into all three. That does make it slightly easier and reduces the possibilities of what I have to look through when I do my cross, but I would get to the same answer if I didn't see that 3 pulled out. It would just take me a little more time working through all the possibilities. So here what I'm doing is I'm making my cross, ignoring this 3 I pulled out, and just working with this equation. 3 times negative 6 gives me negative 18. I bring down this positive 7. So I'm looking for two numbers that multiply to 18, negative, and then add to 7. That means that one of the numbers has to be negative and one of them has to be positive. It's the only way to multiply to a negative number. So really that means the numbers will be subtracted to get to 7. If I take my 18, the ways to multiply to 18 are 1, 18, 2, 9, and 3, 6. I'm looking for the one that subtracts to 7. 18 minus 1 is 17, no good. 9 minus 2 is 7, that's what I'm looking for. Because I want my 7 to end up positive, I'm going to make the bigger number 9 positive, the smaller number 2 negative. If I now tried to multiply them, 9 times negative 2 would give me negative 18. If I tried to add them, 9 plus negative 2 would give me 7. So I keep the 3 outside. I break up after the 3x squared, the 7x, into plus 9x minus 2x, and then I still have the minus 6. 3 stays here from this first term. When I do factor by grouping, I can take out 3x. It leaves me x plus 3. From this second term, I can take out a negative 2, so that it also leaves me x plus 3. That means with the 3 outside, my final answer is going to be outsides 3x minus 2 times insides x plus 3. If you didn't see that the 3 could come out right away, which is perfectly fine, you might end up with an answer where the 3 was multiplied by either of these two. So it could be that if you multiplied the 3 by the first one, you'd end up with 9x minus 6 times x plus 3. Or it could be if you multiplied the 3 to the second one, you'd end up with 3x minus 2 times 3x plus 9. Rest assured, these are all mathematically equivalent, and any of those 3 would be marked correct by Cengage if you gave that answer to this problem.